As I said, we will learn about telescoping series. Let's look at the example and talk about what the telescoping series is. The problem is determine whether the series is convergent or divergent by expressing the partial sum Sn as a telescoping series sum. So this telescoping series is involved to the partial fraction. The first example is summation n equals 1 to infinity 1 over n times n plus 1. So what we want to do is we want to think about the partial sum Sn, and then we will consider the limit of the partial sum. So Sn equals summation I equals 1 to n 1 over I times I plus 1. So Sn is if we just expand this one, then it'll be 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over n times n plus 1. So what we want to do is we want to think about the partial fraction of the given fraction. So we consider 1 over I times I plus 1, and then we put that as A over I plus B over I plus 1. We did something similar when we were learning about the integration technique. After we put like this, we consider the common denominator. So I times I plus 1. And then cross multiplication, A times I plus 1 plus B times I. So this numerator becomes AI plus A plus B times I. So denominator is I times I plus 1. And the numerator, we add them up, then A plus B times I plus A. And then we compare this numerator with this numerator. So we make A plus B, I plus A equals 1. So obviously that just means A plus B, I plus A equals 0 times I plus 1. So A equals 1. And the A plus B, these are the same. And so that equals 0. So A equals 1 plus B equals 0. So B equals -1. So we finally write the fraction 1 over I times I plus 1 as 1 over I minus 1 over I plus 1. And then we go back to this point. So the first one is 1 over 1 times 2. So that can be written as 1 over 1 minus 1 over 2. The second term was 1 over 2 times 3 here. And so that can be written as 1 over 2 minus 1 over 3 plus the last term can be written as 1 over n minus 1 over n plus 1. So that means minus 1 over 2 and 1 over 2 will cancel each other, and the same thing will cancel each other, and then this one will cancel with the previous one. So that is 1 over 1 is 1 minus 1 over n plus 1. Limit n goes to infinity, s of n equals limit n goes to infinity 1 minus 1 over n plus 1. It's because this one was nth partial sum. So if we take a limit for the second one, and then that converges 0 because denominator becomes 0, the infinity. So the limit is 1. So what I was saying was summation n equals 1 to infinity 1 over n times n plus 1 equals 1. Any question? The second one is n equals 4 to infinity 4 over n squared minus 1. As we did in the previous one, we think about the partial sum and we will think about the limit of the partial sum. So partial sum and partial sum
Hello? I think it's frozen. I think it did. Yeah. Yeah. Is she gone? Yeah, she'll probably post it to web courses or something. She said she'd make a YouTube video of the rest of the class and then submit it later. Yeah. All right, boys, I'm dipping.
Yeah, I'm sorry. The today's internet is unstable, as I said, and so it was disconnected in the middle, and it can happen again. I don't know whether there will not be any other problem. So let me continue. So I squared minus 1 can be written as I squared minus 1 squared. So that is I minus 1 times I plus 1. So what we want to do is we want to think about the partial fraction with the fraction 4 over I minus 1 times I plus 1. As we have been doing, it can be written as A over I minus 1 plus B over I plus 1. And then we will follow the routine. Then we think about the common denominator. Common denominator is I minus 1 times I plus 1. And then A times I plus 1 plus B times I minus 1. So that is I minus 1 times I plus 1. And let's just do all the expansion. AI plus A plus BI minus B. And then we combine all things together, then A plus B, I plus A minus B. The denominator is I minus 1 times I plus 1. So we make this numerator and this numerator the same. So we have A plus B, I plus A minus B equals 4. And of course, that means A plus B, I plus A minus B can be written as 0 times I plus 4. Therefore, A plus B equals 0, and A minus B equals 4. So we have two equations, and then we want to obtain A and B. And so we add vertically, and then we have 2A on the left side and 4 on the right side. So A equals A equals 2, right? And we know A plus B equals 0. So B has an opposite sign. So B is -2. So that means that equals I equals 4 to n and A and B. So A was 2 and B is -2. So A is 2 over I minus 1 minus B was -2. So I put negative sign here and 2 I plus 1. So we will try to list all of them. And we start from I equals 4. So 4 minus 1 will make 3. So 2 over 3 minus 2 over I equals 4. So 4 plus 1 equals 5. So that happens when I equals 4. And then we keep on going and going like that and see what happens. When I equals 5, the first term will be 2 over 5 minus 1 is 4 minus 2 over 5 plus 1 equals 6. If I equals 6, then the same pattern will go on. So I increases by 1 each time. So it is 2 over 5 minus 7 over 2 over 7. And I equals 7, then we just increase the denominator. 2 over 6 minus 2 over 8. And so on. And so when I eventually became n minus 1, that becomes 2 over n minus 2 minus 2 over n minus 1 plus 1, so n, right? And the last term is I equals n. So that is 2 over n minus 1 minus 2 over n plus 1. So in this case, the pattern is a little bit more complex because the differences between digit 2 became 2, right? So what is happening here is a minus 5 over 2 over 5 cancels with a minus 2 over a plus 2 over 5. And then this one will cancel with this one. And this one will cancel with the other one. And so this one will be canceled with the next one. And so this one cannot cancel with anything. And this one cannot cancel with anything. But digit 2 will cancel with the terms, previous 2 terms, right? So everything cancel each other. And they eventually, what we obtain becomes 2/3 plus 2 over 4 minus 2 over n minus 2 over n plus 1. So summation n equals 4 to infinity, 4 over n squared minus 1 is limit n goes to infinity Sn. So this was indeed the partial sum, nth partial sum. And we realized D2 will go to 0. And so we have to add D2 to get the final answer. So that is limit n goes to infinity, 2/3 plus 1/2 minus 2/n minus 2/n plus 1. And so, as I said, that is 2/3 plus 1/2 is 2 times 3 will make 6, and 2 times 2 will make 4, plus 3 times 1 will make 3. So 7/6. So any question? Can you explain what the cancel? Well, what's happening here is just this one will skip the next line, and then this one is connected with this. This one is connected with this, and this one will be connected with this one, and this one will cancel with the next one. So I equals 8 and I equals 9. So it should cancel with something, and I equals 9. And then if you write I equals 9 here, and then that will be 2/9 minus 1 will be 8. Minus 2/I plus 1 will be 10, right? And then this one will cancel with this one. Any other question?
Where did the 2/n and 2/n plus 1 come from?
2/n
And
and 2/n plus 1 come from?
yes,
Yeah, the partial sum continues until nth term, right? When I plug in n minus 1 here, 2/n minus 1 will make 2/n minus 2. That is here. And the next term was this one is 2/n minus 1 plus 1, right? So 2/n, right?
gotcha. Okay.
Yeah.
Oh, okay. So just okay. Gotcha.
Yeah.
So you plug in those and the actual values that they come up with. Okay.
Yeah, that's correct. Any other question? Let's do the next problem. So summation n equals 1 to infinity, 4 times natural log of n over n plus 1. So natural log of a over b equals natural log of a minus natural log of b. So that's what we have to use in this case. So now we are not just using partial fraction. Instead of that, we use the logarithmic functions property. So nth partial sum is I equals 1 to n, 4 times natural log of I over I plus 1. So by using this property, the way we will express Sn will be 4 natural log of I minus 4 natural log of I plus 1. So any question about this? No question? Clear? So this time, we will do the same thing. So we start I equals 1. So 4 natural log of 1 minus 4 natural log of 2 plus 4 natural log of 2 minus 4 natural log of 3 plus 4 natural log of 3 minus 4 natural log of 4 plus 4 natural log of n minus 1 minus 4 natural log of n plus 4 natural log of n minus 4 natural log of n plus 1. So we just expanded all things out by plugging in I equals 1 to n, and then we will have this. And so what we observe is adjacent term cancel each other, right? And so everything will cancel up to here. So the remaining term will be just the two term, first one and the last one. 4 natural log of 1 minus 4 natural log of n plus 1. So natural log of 1 equals 0, so this term vanishes. And we think about the graph of natural log, that is y equals natural log of x, which diverges infinity. So that is minus 4 times infinity, so it goes to minus infinity. So that diverges. Any question? Next to the next problem. N equals 1 to infinity, e to the 4 over n minus e to the 4 over n plus 1. So as we have been doing, we will consider the partial sum, nth partial sum, Sn. Then that is I equals 1 to n, e to the 4 over I minus e to the 4 over I plus 1. So we just keep writing like that. So e to the 4 over 1 minus e to the 4 over 2. So we plug in 1 here. And then the next one is e to the 4 over 2 minus e to the 4 over 3 plus e to the 4 over 3 minus e to the 4 over 5. 4 over 4, 1, 2, 3. So 4 over 4. So it goes like e to the, when that is n minus 1, it is 4 over n minus 1 minus e to the 4 over n plus e to the 4 over n minus e to the 4 over n plus 1. So these two will cancel each other, and these two will cancel each other. Just the adjacent one will cancel each other up to here, right? The same pattern. This time it appears as a exponential form, and then what we figured out was the e to the 4 minus e to the 4 over n plus 1 is the nth partial sum. So to evaluate n equals 1 to infinity, e to the 4 over n minus e to the 4 over n plus 1 can be calculated by calculating the partial sum, nth partial sum, and then limit n goes to infinity, e to the 4 minus e to the 4 over n plus 1. So when n goes to infinity, this goes to 0. So what we essentially get is e to the 4th power minus e to the 0 power, which is e to the 4th power minus 1. Any question? So those are telescoping series related technique. So basically what you have to think about is a nth partial sum, and just you list n terms and add them up, and then certain pattern will happen, and just the middle terms will cancel each other. And then with the a lot fewer terms will remain, and then you will think about the limit as n to evaluate the infinite series. The next problem is show that the harmonic series summation n equals 1 to infinity, 1 over n equals 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 is divergent. So in this problem, I will show how to prove harmonic series diverges. But in the end, what you have to remember is a harmonic series means summation n equals 1 to infinity, 1 over n, and that harmonic series diverges. So the proof is pretty tricky. When we think about S2, then that is 1 over 1 plus 1 over 2. And we think about S4, then that is 1 plus 1 over 2 plus 1 over 3 plus 1 over 4. And when we think about S8, then that is S4 plus 1 over 5 plus 1 over 6 plus 1 over 7 plus 1 over 8. So S2 is greater than 1 over 2, and the S4 is greater than 1 plus 1 over 2. So S2 plus, we think about this one and add this one, because 1/3 is greater than 1/4. So plus 1 over 4 plus 1 over 4. And then that is 1 over 1 plus 1 over 2 plus 1 over 2, right? And this one will be S4 plus, again, just we get the smallest one, and then 1/8 plus 1/8 plus 1/8 plus 1/8, because all of them are greater than 1/8. And then what will happen will be, we are adding half amount of 8. And so this part will become 1/2 when we add them up. So that equals S4 plus 1/2. So that is 1 plus S4 is 1/2 plus 1/2 plus 1/2, and so on, right? And so S to the 16th power is greater than 1/1 plus 4/2, because if you think about this one, that is 2 squared, and I know this is 2 squared, this is 2 cubed, and this is 2 to the 4th power. So when this is 2 squared, that is 1 plus 2/2, right? This one. When that is 2 cubed, that is 1 plus 3/2. And when that is 2 to the 4th power, that is greater than 1 plus 4/2. So what we can think about is S to the 2 to S sub 2 to the n power is greater than 1 plus n/2. So this power and this one are the same. So when we take the limit n goes to infinity, S sub 2 to the n is greater than limit n goes to infinity, 1 plus n/2. So this goes to infinity, and so the whole thing goes to infinity. So limit n goes to infinity, S sub 2 to the n power diverges. So this subsequence of the partial sum diverges. So that implies n equals 1 to n, or 1 to infinity, 1/n diverges. Any question? The next theorem will be about a test for divergence, and we will work out the series of problems related to the test for divergence. We will start to do it next Monday. And sorry for the internet related problem today, but anyway, we could finish it. So if you have any question, then you can remain and ask me question.